And I want to introduce next speaker. Paweł has been associated with ASTOR since 2018. He's responsible for designing intralogistics system, interprocess flows, automation, and robotic projects. You may know him from his presentation at the InterMarium Simulation Conference 2023. Today he will give you a presentation titled Identifying Needs and Building a Vision in Intralogistic Projects with the support of FlexSim. Welcome to the stage Paweł Woźny, Solution Architect from ASTOR. A big applause for him. Sorry, Paweł Woźny.
That's no problem, that's okay. Good day, everyone. Nice to see a few familiar faces from the last conferences last year. I have a pleasure to show you our experience using FlexSim in ASTOR. So, but the first I will say a few words about the company itself. This one? Okay. Checking? Oh, much better, yeah. The company focuses on 4 areas: automation, robotization, digital transformation, and intralogistics. I represent the intralogistic team, and we are available in 7 cities in Poland, because we are a Polish company. And in Krakow, we have actually 3 locations, 3 independent locations, and they consist showrooms. There is a robotic showroom, there is an intralogistic showroom, and there is an innovation showroom. There are free to visits. After a small appointment, you can go and see what we have there. Some quite interesting technology, you will find them. At 2023, we made some kind of agreement with InterMarium that we will together promote a FlexSim simulation tool as an industry standard in Poland and part of digital transformation. And we did some good job since then. We published and show some good paperwork. We also we were visible at mutual conferences, and we also create video materials and audio podcasts about simulating, about digital transformations, and about digital twins. Why FlexSim? Each time I try to find a new slogan, and this time it is because we wonder why and wonder how. Wonder how and wonder why, actually. And if you find this sounds familiar to you, you can sing silently. Lemon tree. Yep, exactly. If you don't want to sing right now, there will be another chance. So our simulations consist of the products that we are development. We are a distributor. They can be mobile robots, industrial robots like Kawasaki, mobile robots, I mean Agilox right now, and some commissioning stations, manual commissioning station, automated picking stations, A-frames, and conveyor system, etc. We do simulations, but we try to keep them as simple as possible, because we don't sell simulations. We sell systems, and we do simulations just to check if the system will perform correctly. So we try to do very simplified simulations and conduct them very quickly. And why do we need them? There are a few reasons, but the most important are the first one and the second one, and the last one. We have to convince ourselves that our ideas, our approaches are okay. And when we convince ourselves and we find and choose the best one, at the end of the day, we have to convince the customer, the investor, that our idea is still okay. And what we gained after using FlexSim for about 2 years right now, we speeded up the process of preparation of the project, and also we speeded up the process of making the decisions in the project. This is very important. We also do one more thing. What you can see here is a compilation of video and mobile robot interface, and also a simulation from FlexSim. And we do some kind of validation of the simulation. When we can, we perform a test on site and check if our assumptions in the simulations are almost like the same, like the real behavior of the robot in the system. If they are close enough, we knew that this validation is quite accurate, and I have to add this is a powerful thing. This do a job very, very good, and this boosts our credibility in the eyes of the investor. Case scenario. Yeah, I prepared some example scenario for today, a very simple one, and I enhanced it with some background story. Please don't take it too serious. And it will also contain a lot of small, very simple, I mean really simple, basic simulations, just to show you how such simple simulation can help during building a vision in the early stages of the project, and maybe to easily gather an assumptions of the project if they are not clearly defined at the beginning. But first, one quiz, like always. I should ask if someone recognizes this friendly-looking man. Perhaps no. It's not Monty Hall like the last time. This is Karol Borsuk, Professor Karol Borsuk, mathematician, Polish mathematician, and he was working at geometry topologies. But he did one more thing that he is famous for. And he designed a game. When he lost his job at university during a war, he designed a game, animal husbandry. And the funny thing is that his surname, Borsuk, means badger in English. And this game was popular then, during the war, and it's even more popular right now. This game you can find, this is a Super Farmer. And this game has very simple rules. You have to collect the animals to achieve the goal and exchange them with some kind of exchange rate. For example, 1 pig is equal to 2 sheep. And that's it for now, and I promise I will get back to this later. So, our example scenario, I had to cover some areas of the layout because this is a real layout and they are maybe not important, and I could not show it. And what we can see in the layout. There are 2 production lines that generate the final product that has to be transported to the warehouse. And in the warehouse, there's an automatic wrapper machine, and the pallets have to be wrapped. And right now, they are working with 2 human-operated forklifts, and they are transporting those pallets from the machinery to warehouse. And as you can see, they have a lot to do. Right? So they are getting some rush hours. The management of the company also take care of the mental health of the staff. So they have a lemon tree. Point to you. They have a lemon tree that the staff can chill out. But the most important on this layout right now is this little small dot in here. Right here. This is the plant manager. That day he was standing there and making some observations. And after this observation, he called a meeting with the production staff and asked, are we some kind of fool's garden? And why is that? Because when I was standing near the lemon tree, I saw a forklift driver that was driving too fast and driving too far. Maybe we should change our point of view, so I wonder. And because they know ASTOR already, they decided to call us. Let's call ASTOR. And they did. Yep. And they did what they said. They called some nerd specialists in ASTOR. Actually, this one didn't pick up the phone, so the second one had to. And they described the problem as a lemon tree problem. And after a few words of discussion, I promised that I will get the game and bring on the site to investigate this problem more. You already know what game did I bring. This was a farmer game. Don't take it serious, please. So, we know that we have 2 cows in the layout. But naming someone a cow is unpolite, and it's disrespectful. So let's try another way. We have 2 wild horses. And they have some kind of performance characteristics. But the rules of the game says that we can not change, but they are equal to some bunch of mules. And it really doesn't matter if the mules are arranged in series, or maybe parallel, or maybe even in some chaotic manner, they still represent the same value. And I know you will think that this one looks much cheaper. It's not. It's only so-called maintenance. So what we know, we have 2 forklifts, and they are equal to some number of mobile robots, maybe 4. And if those forklift drivers work from point A to B in this manner, unstructured manner, so the 4 mobile robots will do the same but slower. So we need more robots because they are just slower. Let's see how it looks in the layout. 4 mobile robots are picking up the pallets from production line and transport them to the warehouse area. And it looks quite good. But the plant manager says, there's a problem. We don't have money for 4 robots. Okay, but how much do you have? Maybe for 2. Sorry? Maybe for 2. 4 or 2? 2. Okay, they have for 2. So we have something like this, and we know only 2 robots. Okay, the most basic approach would be something like this. So let's leave 1 forklift, and let's introduce 2 mobile robots, and we are done. So the forklift is twice as fast as mobile robots, but they do the performance like we described. But this is often happening in projects. We see it often, but it needs some kind of attention, because if the mobile robots will meet forklifts in the points of picking the pallets, there is always, or maybe in 80% of the time, there are problems. We don't like each other. They will block each other. There is a risk of collision. So those points should be some kind of separated or treated in a special attention. But everything here is parallel, like the mules was parallel. But we know we can rearrange this. So maybe if we change our approach and define the forklift driver working in the series with some middle point of exchanging the pallet, yeah, we will lose some efficiency, but and also we will lose some extra space. But this will theoretically work. Yeah. So the same thing we can do with the mobile robots. We can divide them in 2s and also give them the middle point of exchange for the pallets. So this could work somehow, but we still see 4 robots. So let's take half of this solution and half of this solution to propose something like this. 1 forklift driver separated from 2 mobile robots that are doing their job in transporting the pallet through the layout. Okay, but one of the problems was the forklift drivers were overspeeding. And this one, because it's only 1 right now, he has to touch every pallet in the system, not half of the pallets like the previous one, but every pallet. And even if we reduced his distance by half, he still have to rush Harry. So to slow him down, we have to grab this slider and move it a little bit to the left. So we reduced his distance. It can work a little bit slower, but probably right now we have to introduce a 3rd robot to achieve and keep the efficiency of the production. Yeah, but if we are greedy on selling the mobile robots, we can even more move this transfer point to the left. So the performance of the forklift will be almost equal to performance of mobile robot. He don't have to speed up. So we have something like this. Still 4 mobile robots, but let's check it in the layout. So what we have here, 1 mobile robot that's transporting a pallet only to the transfer point. He works alone, so no other robots collide with him. There are no problems. And the wide area of the corridors are occupied by 3 mobile robots that transfer the pallets to the warehouse. And this looks good. The plant manager even didn't recognize there are 4 mobile robots, not 2. But he was so tired that day that he fell asleep. And you all know how hard it is to get rid of the bad melody in your head during a day. So he had a bad dream, very, very bad dream. And he was dreaming that someone was singing. I'm sitting here in a boring room. I'm wasting my time. I got nothing to do. I'm hanging around. I'm waiting for you, but nothing happens. Yeah? If we unpack this, maybe someone is missing something, maybe a pallet, but we don't know who that could be, who is singing in the layout. And the second verse, I'm turning my head up and down. I'm turning. Yeah, okay, we know who it is. This is a bad dream, so everything is possible. This is a warehouse operator. He's so bored that he jumped into a wrapping machine and wastes his time doing this. Okay, why is he bored? Because he has some moments when he has nothing to do. There are no pallets to be wrapped. But the biggest problem is, there are moments when almost 2 pallets are bringed by the 3 robots at the same time, almost in the same time. There is no buffer before the wrapping machine. This is even possible that 3 robots in some circumstances will bring 3 pallets. And this is a very stressful situation for the worker there. So we have to flatten this out to normalize this chart and find a solution for a better work and environment for the wrapping machinery. So we have something like this, and maybe we can introduce another temporary pallet station. So let's extract 1 robot and put it like an interface for the wrapping machine. Why I'm calling it an interface? Because it doesn't care. This robot doesn't care who will bring a pallet to him. He knows what to do with the pallet. And it will tag the pallet for the wrapping machine, not 2 pallets at a time, but 1 pallet after another pallet, and it will tag them. Because we reduced the distance for the rest of the robots, only 2 robots will do the job in the layout. Okay, let's take a look how the layout looks. So we have 1 robot interface for the machinery to temporary station, 2 robots transporting a pallets for a second temporary station, and after that we have 1 robot that tags the pallets for the wrapping machine. So looks good, very good, but there are still 4 robots. Yeah. How to implement the system? I only have money for 2. Yeah, if we would go with the first approach, 4 robots in a swarm, and we implement 1 robot, maybe 2 robots at the beginning of the project, and after a while we would like to introduce the second, the third and fourth robot, it will need to re-implement the programs of the first 2 robots. Adding new robots to the system will affect the others that were already working there. So the second approach that divides the project on some phases give us the ability to introduce 2 robots at the beginning, maybe first robot for the interface for the machinery part, the second robot as an interface for the wrapping machinery part, and let's leave the middle point as it was, 1 forklift driver. And after a year, when we collect another money for buying another 2 robots, we can decide if we buy another 2 robots and implement them in the already prepared system, and implementation of this robot will not affect those implemented before, it's quite straightforward. But maybe in the next year, someone will bring some brilliant idea and will find that there is a corridor in the layout that it's too narrow for forklift. It's even too narrow for mobile robot, but it's not too narrow for a conveyor. And after some clearance of this of this corridor, we could end up with something like this: 1 mobile robot picking up the pallets to the conveyor system, and the second robot, or maybe a forklift, delivering the pallets in a good manner to a wrapping machine. So this looks very clear and very simple. After this bunch of possibilities, alternatives, we end up with something like this. And we can decide if we buy 2 robots and conveyor, 1 robot and conveyor, and leave the forklift driver, or maybe we only buy a conveyor and leave 1 and second forklift driver here. So I hope that I convinced you that very simple simulations can help build a vision of the project at the early stages when we don't go into details too much. Thank you.
So thank you for the presentation. Okay. I see that you have some questions maybe. So any of you want to ask our speaker for something? Yeah, there is one question.
I would like to ask what was the history of inventing the new solutions? Because here you talk about let's try this, let's try this, let's try this, and this is usually more difficult. So I would like to ask you if you have like prepared solutions on your side, so or do you like do it on the go after the consultation with the client, what they can do? Do you like have a vision there and first have a brainstorm about?
Well, it depends. It depends. Often client don't know what is his problem, or maybe even he feels the problem, but he's wrong. The problem is in another place. Yeah, okay. We have to discover it. But okay. But on the other side, there are clients that exactly know what they want to have, because they saw it on the other facility or maybe somewhere else, and we try to understand their vision and maybe rearrange them slightly or not, and implement so it will work exactly for them. Well, we don't sell products from the shelf. It's always some kind of iteration work, some fitting. This is our value, so we don't like to ask, what do you want to buy, and we will check if we have it. No, we will want to work together to establish some good solution for the project.
Okay. Okay. Any of you want to? Yes, Philip, there is one question.
It is a very good idea, such many scenarios. What about the distances? Because, you know, if we've got, you know, 1 transporter or 2 transporters on this automatic transporter, and what about these distances? Because the distances along the speed of these transports of these goods, there is a big problem probably. Yeah. In this scenario, you take it into account?
Yes. Adding another temporary stations, of course, you are right, will enlarge the WIP time of transporting the goods through the layout, because we have to be pick it, leave it, pick it again, and leave it once time. So it takes a little bit longer. But unless we are not doing just-in-time production, we are just conveying them to a warehouse. Nobody is waiting for this pallet, nobody. We don't need this pallet to perform another production processes. We just have to bring it to the warehouse. So it's not a problem. Well, distances, we always take into account during the analysis of the project with mobile robots. But fortunately, the larger distance for mobile robot is better than the close distance. Yes, why is that? Because the grabbing the pallet and putting it down takes some constant time, maybe 35 seconds, always. So if I want to transport pallet from this point of the scene to this one, maybe it's 3 meters, it would take not less than 1.5 minutes. So if we enlarge the distance, this picking and leaving the pallet is not a significant value. Yeah? Of course, robots are slower This was the case. Forklifts were overspeeding. I promise you that no mobile robot will overspeed. So, yeah, thank you.
And maybe the last question, because we need to continue. 2 questions, okay.
Thank you. So can you give us more insight on the business value? So for example, what was the investment and what did the client gain by using your solution?
Well, they have problem like most of the facilities in Poland. It was just a simplified project, what I showed you. This project was much larger, but the problem is in today's facilities is humans, where human work, yeah? Availability of the operators. This is a problem. So during a COVID, it showed up during a COVID. So everyone had to search for alternatives of human operators.
Okay, and the last question.
Thank you. My name is Cezary Szweda. I'm from Warsaw University of Technology. I have a question. Did you try to find the optimal solution for your problem?
No, because optimal solution is some kind of multidimensional array. Because optimal in what case? The money, or in the transporting time, or maybe in the space utilization?
So
it depends on the customer needs. So if he direct our ideas in one exact flow, so let's reduce the operators, let's go into the mobile robots. Well, the optimum in what case? Reduction of the operators, or it was optimized in some, I don't know, utilization of the machinery?
Thank you, but I think that it's quite easy to define a mathematical model for such problem. Define source points, delivery points, some variables, parameters, constraints, and in the FlexSim there is an embedded suboptimal solver, and it's another way to find solutions. So my suggestion, and that's all.
Yeah. But like I mentioned before, we try to perform the simulations quite straightforward and simple and do it fast. Yeah. So we have some ideas in each project. It's not a new domain for us. So we have some ideas and we try to fit them. And we not always dig so deeply for each project, because at this stage, this is the beginning of the stage of the project. We are not sure if the project will continue. Yeah.
Okay. Thank you.
Thank you.
Okay, thank you, Paweł. We wonder that you will present something in the next year edition of InterMarium Simulation Conference, maybe with another song. And let's give Paweł a round big of applause once again.